Large language models typically interact with external APIs by generating structured JSON objects. However, this video explores a major paradigm shift, Programmatic Tool Calling, or PTC. Instead of emitting rigid JSON, the model writes executable Python code to interact with tools. We will analyze a comprehensive evaluation across 14 models to see if treating tools as code outperforms the traditional JSON standard. The main takeaway is that traditional JSON tool calling has severe structural limitations. First, for sequential tasks where one tool's output feeds into another, JSON requires multiple round-trip inference turns, which dramatically increases latency. Second, when forced to make many parallel calls, models using JSON start dropping calls entirely once they hit a certain threshold. The core breakthrough of programmatic tool calling is executing complex workflows in a single agent turn. In this paradigm, tools are presented to the LLM as typed Python stubs. The model writes a single Python script that imports these stubs, chains them, or runs them in parallel. The agent loop then executes this script in a secure subprocess, capturing the output in one go. Programmatic tool calling significantly reduces latency in sequential chaining tasks. In a multi-hop scenario, a JSON agent must call the first tool, wait for the environment's response, and then make a second call. With programmatic tool calling, the model writes both calls in a single script and uses its parametric knowledge to handle intermediate logic, cutting execution time in half. Programmatic tool calling handles high parallel fan-out structurally, whereas JSON tool calling fails. For example, Claude Sonnet 5 drops parallel JSON tool calls when the count exceeds 70. In contrast, programmatic tool calling maintains 100% accuracy even at 100 parallel calls because it expresses fan-out using standard Python loops or asynchronous gathering. Programmatic tool calling is highly robust to adversarial context loads. When researchers flooded the context with 128 decoy schemas, JSON tool calling accuracy degraded. Surprisingly, programmatic tool calling accuracy actually improved by 5.5%, as the richer context helped the models better identify the correct functions within a code-like structure. A key finding is that programmatic tool calling viability is determined by model generation rather than model family. All 5 Anthropic models and the 3 newest GPT 5.6 models match or exceed JSON baseline accuracy. However, older models like GPT-4o fail because they output literal new-line escape characters instead of actual new lines, causing syntax errors. While programmatic tool calling is highly promising, some limitations remain. The evaluation used echo return stubs rather than real API executions, and embedding Python stubs in the system prompt increases input token overhead. Nevertheless, this research proves that code-first execution is a highly viable, robust, and efficient alternative to traditional JSON APIs for future AI agents.